Welcome to the Introduction to Logarithms. In this video, we'll be talking about some basic foundation material that will help you when we actually study the logarithms. So let's get started. The first thing we're going to be talking about is the composition of functions. So before we talk about that, let's talk about what a function actually is. So let me give you an example here. So we have f of x is equal to 2 to the x. And this is a function. It has three components to it. We have the function, or f. This can actually be any letter you want. It can be f, g, z, a. And then we have the variable in parentheses. Make sure not to forget the parentheses. And then we have whatever the function actually is. In this case, 2 to the x. So this special type of function actually has a name, and it's called an exponential function. And we will be using these kinds of functions when we actually study logarithms. They're actually very similar to what logarithms are. Other types of functions include linear functions and quadratic functions. So in the linear function would be f of x is equal to 2x plus 3, or f of x is equal to x squared plus 3x minus 9. This one's a quadratic, this one's a linear. They're very, very similar to equations. It's just you replace the y with f of x or g of a. So that's basically what it is. It's just a kind of a different form of an equation, if you want to think about it like that. So how do we evaluate it or kind of solve it? So let's say they say evaluate f of 4. Okay, so basically what you would do is you would replace every single place in the function that has x with 4, because 4 is in the parentheses now. So it would be 2 times 4 plus 3, which is equal to 12 plus 3, which is equal to 15. So f of 4 is equal to 15. Now the reason why I say you replace every single place where x is with the number is because if we look at this one here, x appears more than once, right? We have the x here and we have an x here. So we're going to replace 4 in both of these places if we were asked to evaluate f of 4. Alright, so now that we've covered what a basic function is, let's look at some more complex functions, or basically a composition of a function. So a composition of a function basically kind of calls on two functions at the same time. So let's say we're given that f of x is equal to 2x plus 3, and we're said that g of x, a different function, is equal to 5x minus 5. So now they tell us to evaluate g of f of 3. Alright, so they're calling on two functions, both of these functions, at the same time. So the way you would evaluate this is kind of like how you would evaluate something with parentheses and brackets or something. You would evaluate inside out. You would first crack the inner parentheses or inner function, and then you would slowly move your way outwards. So in this case, what you would do is you would first evaluate f of 3 and plug it in and get what you get. And whatever you get here, you would now plug into the g function, and whatever you get there is your final answer. So let's try it out. So f of 3. First we have to do f of 3. So f of 3 is equal to 2 times 3 plus 3, which is equal to 6 plus 3, which is equal to 9. Sorry, 6 plus 3, which is equal to 9. So now we plug in the 9 into the g equation, or correction, g function. So we have g of 9 is equal to 5 times 9 minus 5, which is equal to 45 minus 5, which is equal to 40. So therefore, g of f of 3 is equal to 40. So that's how you do a composition of a function. And now we're actually going to talk about how this relates to logarithms and talk about this thing called the inverse of a function. Before I go over both of the ways to find the inverse to a function, let's go over this little inverse rule right here. So the inverse rule tells us that if you have two functions, f of x and inverse of x, so f to the negative 1 of x basically means the inverse function of x. So I'll just put that as a note here. Inverse of x. So if you have f of x and the inverse of x, then that means that f of the inverse of x and the inverse of x of the inverse of f of x are both equal to x. So that means that f of the inverse of x is equal to x, and the inverse of x, the inverse of f of x is equal to x. So that basically, that's what makes two functions an inverse. So if you get a question like r f of 3x and if you get something like if f of x is equal to 3x and g of x is equal to 1/3 x, are they inverses? And the way you would find that is you would basically do that right there. And I could tell you that they are indeed inverses. And if you plug it in, I won't plug it in for time purposes, but if you plug it in, there are inverses. So one important thing you have to remember here is that both of the statements here, both have to be true in order for two functions to be inverses. If one of them is true and one's not, then they are not inverses. Alright, so how do we find the inverse? So there's two ways of finding the inverse of a function. So the first way is going to be graphically. This is probably what you'll do the least because it's a lot of work. And the way you would do that is that you have this exponential function right here. So this is what an exponential function looks like. It when y is greater than 0, it's going to be exponential growth. And then when y is less than 0, it's going to kind of become a gradual curve and sort of flatten out, but it'll never touch the x-axis. That's one thing to remember. So I made a table of values. I found a bunch of points, and I plotted them. And then I also have this other line, which is y is equal to x. That's the line y is equal to x. Alright? So when you find the inverse of a function, basically what you're doing is you're reflecting this function over the line of y is equal to x. So you're basically kind of reflecting it over that line. And the way you would find the new points for the inverse is basically you would switch the x and y coordinates. So if xy is on a line, then that means that yx is on the inverse, the line of the inverse equation, or correction, inverse function, so to speak. So we have the point 0, 1 in the function, which means that in the inverse, the point will now be 1, 0. So let's now make a table of values for the inverse function. So it'll be 1, 0, 2, 1, 4, 2, 1/2, negative 1, and 1/4, negative 2. So now let's plot this. We have 1, 0. It's a different color. So we have 1, 0. We have 2, 1. We have 1, 2, 3, 4, 2. We have 1/2, negative 1. And we have 1/4, negative 2. So now if I draw a quick sketch of a line right here, it's not perfect, but it gives the general idea. Then we have that. So this is the inverse. And this is how you do it graphically. Now, algebraically would be the other way to find the inverse of a given function. So we know that these two are inverses, but how do we find that? Well, what we would first do is there's 3 steps to doing it. Or it would be actually 4 steps. But the first step would be to change the f of x to y. So now you now make it an equation. So y is equal to sorry, it was actually f of x is equal to 3x, and the inverse of x is equal to 1/3 x. Sorry. So y is equal to 3x. And now what you would do is, like you did over here, you would now switch the x and y. So it would now be x is equal to 3y. And now, like you did before, you would now isolate y. So we get, if we divide both sides by 3, we get y is equal to x over 3, or 1/3 x. And now, since it's still in equation form, we have to write it in a function form. So it would be f inverse of function of x is equal to 1/3 x. And that's basically what we have right here. So that's how you would find the inverse algebraically. So that ends our introduction to logarithms. With the foundation material that we've built in this video, we can now move on to logarithms and discussing what they are, what we can do with them, and how they make our lives easier. So thanks for watching.